Beneath the geysers, the hot springs, and the vast wild landscapes of Yellowstone National Park lies one of the largest volcanic systems on the planet, a great reservoir of heat and partly molten rock that has, in the deep past, produced some of the mightiest eruptions in the geologic history of North America. And here is something that surprises many people. The ground above that system is moving. It rises and it falls. It swells and it settles, shifting by measurable amounts as the years pass. And scientists watch these movements with a careful and constant eye. To hear that the ground at Yellowstone is moving can sound alarming, like the first tremor of a coming catastrophe. But the reality is far more fascinating and far less frightening than that. This is the story of Yellowstone's moving ground, of what those movements actually are, of why they happen, and of what scientists are watching now. But before we go a single step further, one essential and honest word. The movement of the ground at Yellowstone is not a sign that an eruption is coming. It is a normal, ongoing feature of this living volcanic system, one that has been happening for as long as scientists have been able to measure it. And Yellowstone is not overdue for an eruption, a common myth that has no basis in how the volcano actually behaves. What follows is not a warning of impending doom, but an honest look at a remarkable natural phenomenon and at the extraordinary science that keeps watch over it. Quick honest word before we dive in. A lot of people watch these all the way through, love them, and forget the one small thing that keeps a channel like ours going, hitting subscribe. If you are finding this fascinating, take 1 second and subscribe right now. It genuinely matters for us and costs you nothing. And drop your state or country in the comments so we can see who is watching. All right, let's begin. What it really means when the ground moves to understand what scientists are watching, you first have to understand what it actually means to say that the ground at Yellowstone is moving, because the phrase can conjure images far more dramatic than the reality. The movement in question is a slow, gradual rising and falling of the land's surface across the great volcanic depression known as the caldera, a shifting that unfolds over months and years rather than in sudden jolts. The ground does not heave or lurch in a way that anyone standing on it would feel. The movements are measured in inches and centimeters, detectable only with precise scientific instruments, and they would be entirely invisible to a visitor walking through the park. Yet over time, these small movements add up, and the land can rise or fall by significant amounts across the broad expanse of the caldera. This phenomenon is known as ground deformation, the swelling and settling of the Earth's surface. And it is one of the most closely watched aspects of Yellowstone's behavior. The deformation is not uniform across the park, but varies from place to place, with some areas rising while others fall, and the pattern shifting over time. It is a dynamic, ongoing process, a slow breathing of the land that reflects the restless activity of the great volcanic system below. Understanding that the movement is this kind of slow, subtle deformation, rather than any violent shaking or dramatic upheaval, is the first step toward understanding why scientists watch it so closely, and yet remain calm about it. The moving ground is a signal, a window into what is happening beneath the surface, and learning to read that signal is one of the central tasks of the scientists who study the volcano. Why the ground rises and falls. So why does the ground at Yellowstone move at all? The answer lies in the great system of heat, molten rock, and hot fluids that lies beneath the caldera, because it is the shifting of these materials deep below that pushes the surface up and lets it settle back down. Beneath Yellowstone sits a vast reservoir of partly molten rock, and above and around it move enormous quantities of hot water and gases circulating through the rock under tremendous pressure. When these underground materials accumulate or expand in a particular area, they push upward on the rock above them, causing the ground surface to swell and rise. When they drain away, cool, or shift elsewhere, the pressure eases and the ground settles back down. This constant movement of molten rock and hot fluids beneath the surface is what drives the rising and falling of the land above. It is important to understand that this movement of underground fluids and rock is a completely normal part of how a large, active volcanic system behaves, not a special or alarming event. Yellowstone is a living system, its underground plumbing constantly in motion. And the deformation of the surface is simply the visible expression of that ceaseless activity below. The ground has been rising and falling in this way throughout the entire period that scientists have been able to measure it, going through cycles of uplift and subsidence, sometimes rising for a period of years and then settling back, sometimes shifting from one area to another. These cycles are the ordinary rhythm of the volcano, the slow breathing of a great system that is very much alive but not, by any means, on the verge of erupting. The rising and falling of the ground is thus best understood not as a countdown to catastrophe, but as the normal pulse of a restless giant, a sign of life rather than a sign of imminent danger. And it is precisely because it is so normal and so revealing that scientists watch it with such interest. A helpful way to think about the moving ground is to imagine the caldera as breathing, slowly inhaling as the underground fluids and heat accumulate and push the surface up, and exhaling as they drain away and the surface settles back. This breathing is not steady or perfectly regular, but it captures the essential character of the movement, a slow, ongoing rising and falling that reflects the shifting of materials deep below. Much of this movement is driven not by the molten rock itself surging upward, as many people might assume, but by the behavior of the hot water and gases that circulate through the rock above the molten reservoir, moving from place to place, accumulating and dispersing, and pushing the surface up and down as they go. This hydrothermal activity, the movement of hot fluids beneath the surface, is a major driver of the deformation, and it is a reminder that the moving ground reflects the complex plumbing of the volcano rather than any simple approach of magma toward the surface. Understanding that the breathing of the caldera is largely the work of these circulating fluids helps to demystify the movement and to underscore how ordinary and non-threatening it truly is. Here is something I would genuinely love to know, and it takes 10 seconds. Did it surprise you to learn that the ground at Yellowstone is constantly rising and falling, and that this is completely normal? Drop a yes or no in the comments, because your reactions help us understand what surprises people most, and I read every reply. Okay, back to it. The breathing caldera across the years to fully appreciate why the moving ground is not cause for alarm. It helps to understand the long history of these movements, because scientists have observed the caldera rising and falling through repeated cycles over many years, and this history reveals a pattern of ordinary behavior rather than a march toward eruption. Over the decades that Yellowstone has been carefully measured, the caldera has gone through episodes of uplift, when the ground rose steadily over a period of years, followed by episodes of subsidence, when it settled back down again. Sometimes the center of the uplift has shifted from one part of the caldera to another, and the overall pattern has been one of ongoing, restless movement. A ground that never quite holds still, but rises and falls in a slow, continuing rhythm. This long record of rising and falling is enormously reassuring, because it shows that the movement of the ground is not a new or unusual development, but a persistent, characteristic behavior of the volcano, one that has continued year after year without leading to any eruption. If the movements of the ground were reliable signs of an approaching eruption, then the many cycles of uplift and subsidence observed over the years would have produced one, and yet the volcano has continued in its slumber, breathing slowly through cycle after cycle. The history of the moving ground thus places the current movements in context, revealing them as part of a long-established pattern rather than a novel or threatening event. Scientists who study Yellowstone have watched this breathing caldera through many of its cycles, and this deep familiarity with its behavior is part of why they can observe the ongoing movements with calm understanding rather than alarm. The ground has been moving like this for as long as anyone has been able to watch, and the volcano has slept through all of it. A pattern that speaks powerfully to the ordinary, non-threatening nature of the phenomenon. The tools that watch the moving ground, given that the movements of the ground are far too small to see or feel, how do scientists detect and track them, and what exactly are they watching with? The answer lies in an array of sophisticated instruments and techniques that together allow researchers to measure the deformation of the land with remarkable precision. One of the key tools is a network of instruments on the ground that use signals from satellites to determine their exact position so precisely that they can detect movements of the land surface of just fractions of an inch. By tracking how the positions of these instruments change over time, scientists can map the rising and falling of the ground across the park in fine detail, watching as different areas swell and settle. Another powerful technique uses satellites in space to measure the deformation of the ground from above, comparing images of the land surface taken at different times to reveal how it has moved in the interval between them. This satellite-based approach can map the deformation across the entire caldera at once, producing detailed pictures of where the ground is rising and where it is falling. And it has become one of the most valuable tools for understanding the movements of the land. Alongside these deformation measuring tools, scientists also keep watch with instruments that detect the shaking of the earth, monitoring the earthquakes that accompany the volcano's activity, as well as tools that measure the gases escaping from the ground and the behavior of the thermal features. Together, this array of instruments forms a comprehensive monitoring system, a constant and vigilant watch over every aspect of the volcano's behavior. The data these instruments gather flows continuously to the scientists who study the volcano, allowing them to track its behavior in something close to real time and to build up, year after year, an ever more detailed picture of how the system works. This combination of ground-based instruments and satellite observation is remarkably powerful because each approach reveals things the others might miss, and together they leave few of the volcano's movements unrecorded. The result is that the moving ground at Yellowstone is measured with a precision that would have astonished earlier generations of scientists. Its every subtle rise and fall captured in the data. The scientists who operate this system are able to detect even the subtlest changes in the moving ground, and this ability to watch so closely is a large part of why the situation at Yellowstone is so well understood and so carefully managed. What scientists are watching now is, in large part, the data streaming in from this remarkable network, the continuous record of a volcano's every breath, the earthquakes that come with the movement. Alongside the rising and falling of the ground, scientists watch another closely related phenomenon at Yellowstone: earthquakes, which occur in the park frequently and which are intimately connected to the movements of the underground fluids and rock. Yellowstone experiences a great many earthquakes, the large majority of them so small that no one feels them, detectable only by the sensitive instruments that monitor the park. These earthquakes are a normal part of the volcano's behavior, caused by the movement of fluids beneath the surface, the shifting of rock, and the ordinary stresses of a dynamic geologic system, and they occur in the thousands over the course of a typical year. Sometimes these earthquakes happen in clusters, known as swarms, in which many small quakes occur in a particular area over a period of days or weeks, and these swarms are among the events that scientists watch with particular attention. A swarm can reflect the movement of fluids or the shifting of rock beneath the surface, and it is a natural part of the volcano's activity. Though scientists study each one carefully to understand what it reveals about the system below, it is important to emphasize that these earthquakes and swarms, like the movement of the ground, are normal features of Yellowstone's behavior, not signs of an impending eruption. They are the ordinary seismic pulse of a living volcanic system, and the vast majority of them pass without any significance beyond what they teach scientists about the workings of the volcano. What scientists watch is not any single earthquake, but the overall pattern of seismic activity, looking for changes that would stand out from the normal background, and the constant, low-level rumble of small quakes is simply part of the ordinary life of the restless giant beneath the park. Quick pause, because this is worth sharing. If you are finding this fascinating, tap the like button. It really does help the video reach more curious people. And if you have family or friends who love science, geology, or Yellowstone itself, share this with them because it is genuinely interesting to understand. One like, one share to someone you care about, and let's keep going. The thermal features and the gases beyond the moving ground and the earthquakes. Scientists keep watch on two more windows into the volcano's behavior: the thermal features that make Yellowstone famous, and the gases that escape from the ground. The park's geysers, hot springs, mud pots, and steam vents are the surface expressions of the great heat below, and their behavior can change over time in ways that reflect what is happening in the underground system. Scientists monitor these thermal features, watching for changes in their temperature, their activity, and their patterns, because such changes can offer clues about the movements of heat and fluids beneath the surface. The famous geysers, with their eruptions of hot water and steam, are themselves a kind of natural instrument. their behavior tied to the plumbing of the hydrothermal system. The gases that escape from the ground are another important thing to watch, because the volcanic system releases gases that rise to the surface and vent into the air. And the amount and composition of these gases can reveal information about the activity below. Scientists measure these emissions, tracking how they change over time as part of their comprehensive effort to understand the volcano. Like the moving ground and the earthquakes, changes in the thermal features and the gases are usually part of the normal variation of the system. The ordinary fluctuations of a dynamic volcanic landscape. Yellowstone's hydrothermal features are constantly changing, with geysers altering their patterns, hot springs shifting their behavior, and new features sometimes appearing while others fade, all as part of the natural life of the park. Scientists watch all of this not because any particular change signals danger, but because together these observations build a complete picture of the volcano's behavior, allowing researchers to understand its normal rhythms so thoroughly that they would readily recognize anything truly out of the ordinary. This comprehensive watch is what makes the monitoring of Yellowstone so reassuring, because the volcano is understood in such detail. What would actually signal concern? A natural question, given all this watching, is what scientists would actually be worried about. What kind of change would signal genuine concern rather than the normal breathing of the volcano? And understanding this is key to keeping the moving ground in proper perspective. The truth is that the normal movements of the ground, the ordinary earthquakes and swarms, and the usual changes in the thermal features and gases are all part of the expected behavior of the volcano, and none of them, on its own, signals an approaching eruption. Scientists understand the normal rhythms of Yellowstone so well that they can distinguish the ordinary from the extraordinary, and it would take a dramatic and sustained departure from the normal patterns to raise real concern. A genuine warning of a large eruption would not be a subtle or ambiguous thing, but would involve a clear and sustained escalation across many of the signals at once, a dramatic increase in earthquakes, a rapid and accelerating deformation of the ground, major changes in the thermal features and the gases, all building together over a period of time in a way that stood far outside the normal. Range. The movement of the enormous quantities of molten rock required to feed a great eruption would produce unmistakable signs, likely over a long period, giving ample warning of what was happening. This is one of the most reassuring facts about Yellowstone, that a large eruption could not sneak up without warning, because the buildup would be detected by the very monitoring system that watches the volcano so closely. What scientists watch for then is not the normal movement of the ground, but any sign of such a dramatic and sustained escalation, and the fact that they see no such thing. Only the ordinary rhythms of the restless giant is precisely why they remain calm even as the ground continues its slow rising and falling. The moving ground is not a warning, it is the normal pulse of the volcano, and the scientists watching it know the difference. All right, I know, second time I am bringing this up, feel free to sigh at me. But quickly, if you have made it this deep into a video about Yellowstone, you clearly find this stuff fascinating, and a lot of you who watch have not subscribed yet. That one tap genuinely tips the scales for a small channel like ours. No guilt, just a grateful ask. That is the last time, promise. Let's finish. Why the watching matters, it might be asked. Why scientists devote such effort to watching the moving ground and the other signals of a volcano that is not going to erupt anytime in the foreseeable future. And the answer reveals something important about the value of this work. The watching matters. First, because it is only through such careful, continuous monitoring that scientists can know the volcano is behaving normally, that the movements of the ground fall within the expected range, and that there is no cause for concern. The reassurance that Yellowstone is not on the verge of an eruption is not an assumption, but a conclusion, one that rests on the constant stream of data from the monitoring network, and without that watching, we would not have the confidence we do about the volcano's state. In this sense, the watching is what allows us to be calm, because it replaces guesswork and fear with knowledge and understanding. The watching matters too, because it deepens our scientific understanding of how great volcanic systems work, knowledge that has value far beyond Yellowstone itself. By studying the moving ground and the other behaviors of this well-monitored volcano, scientists learn about the processes that drive volcanoes everywhere, building an understanding that helps in the monitoring and assessment of volcanic hazards around the world. Yellowstone, precisely because it is so closely watched, has become a kind of natural laboratory, a place where the workings of a large volcanic system can be studied in extraordinary detail. And the watching matters, finally, because it ensures that if the volcano ever did begin to behave in a genuinely unusual way, the change would be detected early, giving the maximum possible time to understand and respond. The vigilance is a form of preparedness, a standing watch that protects not by preventing the volcano's natural behavior, but by ensuring that behavior is always understood. What scientists are watching now, then, is not a threat looming over us, but a magnificent natural system whose every movement teaches us something, and whose careful observation is a triumph of human curiosity and care. Keeping the moving ground in perspective, having explored what the moving ground is, why it happens, and what scientists watch, we can step back and put the whole phenomenon in its proper perspective, because the perspective is what transforms a potentially frightening subject into a fascinating one. The movement of the ground at Yellowstone is a normal, ongoing feature of one of the world's great volcanic systems, a slow breathing of the land that has been happening throughout recorded observation and that reflects the restless but not dangerous activity of the system below. It is watched not because it signals danger, but because it is a valuable window into the workings of the volcano. And because understanding it is part of the ongoing scientific effort to comprehend one of the most remarkable natural systems on the planet. The moving ground is a sign of a living volcano, not a dying one or an erupting one, and its movements are the ordinary rhythms of a giant that has slept, in the sense of not producing a great eruption for a very long time, and shows every sign of continuing to do so. It is also worth emphasizing one more time how thoroughly Yellowstone is watched, because this vigilance is a profound source of reassurance. The volcano is among the most closely monitored on Earth, its every movement, tremor, and change tracked by a dedicated network of instruments and a community of scientists devoted to understanding it. This means that the situation is known in extraordinary detail, that the normal rhythms are well understood, and that any genuine change would be detected early and studied carefully. The moving ground, far from being a hidden threat, is one of the most transparent and well understood aspects of the volcano, its every rise and fall recorded and analyzed. To learn about Yellowstone's moving ground is therefore not a reason for fear, but an invitation to wonder, a chance to appreciate the extraordinary forces at work beneath one of our most beloved landscapes and the remarkable science that allows us to watch them. The ground at Yellowstone is moving, as it always has, and scientists are watching, as they always do. And in that steady watching lies not a warning, but a reassurance, the quiet confidence of a system understood, a giant observed, and a natural wonder appreciated for the marvel that it truly is. So the next time you hear that Yellowstone's ground is moving, you can set aside any fear and feel instead a sense of wonder, knowing that what you are hearing about is the slow, steady breathing of a living volcano, watched over with care and posed